video, we are going to look at evaluating the 6 basic trig functions. You likely know about sine, cosine, and tangent from geometry. Maybe you were exposed to the others in Algebra 2 as well. If you weren't, I'm going to talk about them. So here are the 6 basic trig functions. So we have sine, cosine, and tangent like you are used to. Okay, then we have their reciprocal functions. So the reciprocal means that you flip it over. So right, this is sine over 1. Cosecant is 1 over sine. Okay, so it's the same thing as if you flip over the sine function. Secant is the reciprocal of cosine, so it is 1 over cosine. And then cotangent is the reciprocal of tangent, so it is the same as 1 over tangent. So if we take a look at, let's remember, for the sine function, so if you remember going back to geometry and you learned so, ka, toa. So the sine function was equal to the opposite over the hypotenuse. Cosine was the adjacent over the hypotenuse. Tangent was the opposite over the adjacent. Cosecant then would be the flip of that, so it would be the hypotenuse over the opposite. Secant would be the reciprocal of cosine, so that would be the hypotenuse over the adjacent. And then cotangent would be the flip of tangent, or the reciprocal of tangent, so adjacent over opposite. And then again, remember that all of these are relative to where the angle is. Okay, so this is the opposite side as long as theta is here. If theta were here, so if this were a different angle, let's say it's alpha. So if I were to be looking at alpha, this would be the opposite across from alpha, and this would be the adjacent next to it. So it's all dependent on where that angle is. All right, so let's take a look at evaluating all 6 of those functions. So let's take a look at our triangle over here. We need all 3 sides. So we're going to have to quickly do the Pythagorean Theorem here to find the missing side. So we will do 4 squared plus 9 squared, okay, for your Pythagorean Theorem. So 4 squared plus 9 squared should equal that hypotenuse squared. So we have 16 plus 81. So c squared is equal to 97, and then we will square root that to get square root 97. And I'm just going to leave it as square root 97. All right, so then we would go ahead and start evaluating trig functions. So we will start with sine of theta. So sine is, again, the opposite, okay? And so the opposite of theta is going to be the 4. So sine is going to be 4 over the hypotenuse, and so the hypotenuse is always across from the 90-degree angle, so that is square root 97. So then the reciprocal function of sine is cosecant, so the cosecant of theta is going to be the flip of that, so that's going to have square root 97 on top and 4 on bottom. Cosine of theta, so cosine is equal to the adjacent. So the adjacent side is the 9, so the one right next to it, that's not the hypotenuse. So 9 over the hypotenuse, which is square root 97. So then the secant is the reciprocal of cosine. So the secant is going to be the flip of that. So square root 97 over 9, or hypotenuse over adjacent. Tangent is the opposite, so the opposite is 4 over the adjacent, which is 9. Reciprocal of tangent is cotangent, so cotangent is going to be 9 over 4. All right, then special right triangles are you're gonna need to make sure that you remember these from geometry. So for a 40, and we're gonna need to know them in degrees and radians, okay? So a 45-degree angle in radians is pi over 4. So a 45, 45, 90, or a pi over 4, 90, well, actually pi over 2, because in radians, 90 would be, 90 would be pi over 2 radians. But so if you see any of these, you need to automatically know the side lengths that go along with them. So for a 45, 45, 90, remember that this is isosceles, so the legs are the same. So I would just use a 1 because that's the simplest measurement. And then if you do a quick Pythagorean theorem, 1 squared plus 1 squared is 2, and then square root that, you get the hypotenuse of square root 2. So anytime you see a 45-degree angle, okay, remember the proportions of the sides. So same thing here, 1, 1, square root 2, if you see the radians. Then for a 30, 60, 90, or 30 degrees in radians is pi over 6. 60 in radians is pi over 3. So for these, remember that it was 1, square root 3, 2. So across from the pi over 6 is going to be a 1. Across from the across from the pi over 3 is going to be a square root 3. And across from the 90, or the pi over 2 in radians, is going to be a 2. So remember these triangles, have them written down somewhere. So when you get something like this, evaluate all of the trig functions for this given angle. You can sketch a triangle for yourself. So this angle here we'll call, well, actually pi over 3 is like a 60-degree angle, so let me draw it a little bit more. I could have just put it in that bigger angle. So pi over 3 is like a 60-degree angle. So then you can draw the side lengths on. So across from the pi over 3 would be square root 3. This would be pi over 6. Across from that is 1. And across from the right angle is the 2. So now you have all of the side lengths and you can evaluate. So then cosine of pi over 3, cosine is adjacent, which is 1, over hypotenuse, which is 2. Cosecant would be the flip of that. So cosecant of pi over 3 is going to be 2 over 1, or just 2. Sine of pi over 3, so sine is opposite over hypotenuse. So opposite of the pi over 3 is square root 3. Hypotenuse is 2. Oh, what am I doing? I did this wrong. Sorry. Cosecant is the flip of sine. I am losing it because I put cosine first. So the S goes with the C. So sine and cosecant. So this one should have been secant of pi over 3 is the reciprocal of cosine. So secant is 2. I'm sorry. And then cosecant is the reciprocal of sine. So that should be 2 over square root 3. And then tangent of pi over 3 is going to be opposite. So opposite of the pi over 3 is square root 3. Adjacent to the pi over 3 is 1. And you could just say square root 3. And then cotangent of pi over 3 is going to be 1 over square root 3. So then for the 45 degrees, so remember that this is an isosceles right triangle. So we would do, and it doesn't matter where you put the 45 since they're both the same. So the legs are both 1, and then the hypotenuse is the square root 2. So if we do all of the trig functions here, so cosine of 45, so cosine is adjacent, which is 1, over hypotenuse, which is square root 2. Reciprocal function is secant, so secant of 45, so flip the cosine, so just square root 2. Sine of 45 is going to be opposite, which is 1, over hypotenuse, which is square root 2. So sine and cosine are the same when it's a 45-degree angle. Cosecant then of 45 is going to be square root 2. Tangent of 45 is going to be opposite side 1 over adjacent side 1, so just 1. And then cotangent, if you flip that, is just going to be 1 as well. So then when you get special right triangles, you're going to have to solve for some of the missing sides in order to, so find the side length x here. So these are all 45, 45, 90. So let me draw the parent triangle up in the corner here. So remember that it's 1, 1, square root 2. So if you just go back to geometry and proportioning these out, so the x is the leg, that goes with the 1. The square root 6 is the hypotenuse, that goes with the square root 2. Okay, so then you can just solve this, just set it as a proportion. So x over 1 is just x. Square root 6 over square root 2, those are both radicals, so we can divide the insides. So square root 6 divided by square root 2 is square root 3. This one, hypotenuse is square root 2 on every 45, 45, 90. It is similar to square root 2. Leg goes with the 1. And then again, you can set up a proportion here. So x over square root 2 is equal to square root 5 over 1. So this one, we're going to cross multiply this square root 2 up. So we can get x alone. So x is equal to, now square root 2 times square root 5, again, both are inside of a radical, so you can multiply those together to get square root 10. This problem also says to make sure that we have it in simplest radical form and there's a rational denominator. There's no perfect squares in a 10, so we will leave it. Final 45, 45, 90 triangle, and again, this would be the exact same if this said pi over 4 here. So the leg is with a 1, and the hypotenuse is with a square root 2. So x over 1 is equal to 6 over square root 2. So x over 1 is done, that's just x. So now we have to rationalize the denominator. So rationalizing a denominator means that you can't have a radical down there. So remember that a square root wants to undo a squared exponent, so we give it the other half of its square. So 2 times 2 would be 2 squared. So we're going to multiply square root 2 to both top and bottom here. So top is going to be 6 square root 2. Bottom would be square root 2 times square root 2, which is, let me just do this off to the side. So this is going to be square root 4, right? And the square root of 4 is just 2. So this one's going to have a denominator of 2, so we got rid of or rationalized that radical out of there. And then since these two are both outside of the radical, we can divide those. So 6 divided by 2 is 3, and then we still have that root 2. Then 30, 60, 90 triangles. So again, let me draw the parent triangle here. So across from the 30-degree angle is the short side, the 1. Across from the 60 is the square root 3, and across from the hypotenuse is a 2. So for this one, this is across from the 30, so it goes with a 1. The hypotenuse goes with a 2. So then we can do x over 1 equals square root 6 over 2. Again, this is already solved for. So we just have x equals, and then literally just square root 6 over 2. Nothing can simplify there since the 6 is under a radical and the 2 is not. So that is your x. In this second one, again, same 2 sides. So we've got the short side, which is a 1, and the hypotenuse, which is a 2. So we get x over 1 equals 4. Whoa, why did I write square root 2? I said 2, I think. Okay, over 2. So then 4 over 2. So x over 1 is just x, and then 4 divided by 2 is 2. This last one has the long side and the hypotenuse. So remember that the long side is a square root 3 that it goes with, and the hypotenuse is a 2. So this time we have x over 2 equals square root 6 over square root 3. Now, what I would do to solve for x is just multiply both sides by 2 so that this 2 is gone. So I would just multiply by 2 here. So those will cancel. So you'll have x equals 2 root 6 over root 3. And then since you've got the 6 and the 3 both under square roots, they can divide. So 6 divided by 3 is 2, still under the square root. So 2 root 2 is the length of x there.